Hello. Just wanted to help you graph linear inequalities a little bit. The first problem I saw was number 9. I don't know if you needed help with that or not, but feel free to fast forward if you need to. Remember that they're just trying to have you figure out if 0, 0 works in this system of linear inequalities. It's pretty easy to do. Remember that the first part of your ordered pair is always an x value, and the second part of your ordered pair is always a y value. So we start by just letting x equal 0 and y equals 0 into our two statements. So we can call this one statement 1, call this one statement 2. So in the first statement, we're asked to figure out, does 0, 0 work in the inequality y is less than or equal to x plus 7. So all you would do was take a second to plug in, or substitute, as the big kids say, the y value of 0 in for y, and 0 in for x in the second, or the right side of that inequality. So I'm going to let y equal 0. And I'm also going to let x equal 0. And then I'm going to simplify both sides. So in doing so, I just kind of add 0 to 7 on the right side. 0 plus 7 is 7. So I'm asking myself, is 0 less than or equal to 7? And the answer to that question is yes. So that makes us pretty happy. It definitely works in the first statement. On to statement 2. In statement 2, we're asked if 0, 0, so an x value of 0 and a y value of 0, would work in the expression y is greater than or equal to 2x plus 3. So you would let y equal 0, and you would let x equal 0, and then simplify both sides of the inequality. So obviously 0 is already simplified. And then on the right side there, you got to do your order of operations. So we got to multiply before we add. So 2 times 0 is 0 plus 3. Continuing to simplify a little bit. 0 plus 3 is 3. So we got to ask ourselves, is 0 greater than or equal to 3? And the answer to that is no. That does not work. So what we can learn from this is that the point 0, 0 would not be in the shaded region for the solution of that system of inequalities. So this is not an answer. The answer to question number 9 is no, because it has to work for both, not just one or the other. But on to graphing. Okay, so this is number 11. They want you to full out graph your system of linear inequalities. So I'm going to start just by graphing y is greater than negative 3. And y is greater than negative 3. In order to graph that, I got to remember that when I have y equals a number, that makes a horizontal line. That's a constant graph. So for a hot second, I just ignore the fact that this is actually an inequality problem. I just kind of pretend that this is an equal sign for starters. So I start just by graphing the line y equals 3. I guess I should say negative 3. So I'm going to pretend that I'm just going to graph the line y equals negative 3 to start. So I would go to where y, so this is your y-axis, this is your x-axis, and I would go to where y is negative 3 on that axis, and I put a dot. So that is the spot on the y-axis where y is negative 3. We can't draw a vertical line through this because that would be the y-axis, and that just doesn't make a ton of sense. What we would need to do is graph the line in the opposite direction, so that's why it ends up being horizontal. So I just graph where y is negative 3, and I draw my horizontal line. I have a cool little way of remembering, that y equals a number is a horizontal line, but I can get into that if you need me to. So this is the line y equals -3. So I always draw it and label it so I can keep track of what I'm doing. Notice I drew a dashed line there because at the end of the day, I'm not asked to just graph y equals -3. I'm asked to graph y is greater. So, ooh, I got a lightsaber here. I got to graph y is greater than -3. So I'm not allowed to include -3 in the solution set. I have to graph values that are strictly above or greater than -3. So y values that are above -3 would be values like -2 and -1 and 0. Those are all numbers that are bigger than -3. That tells me where I got to color in. So I'm going to shade above that line right there because these are numbers that are greater than -3. Try to get as much of it as I can. And that's the first linear inequality done. However, there's two. So now we got to do y is greater than or equal to 5x. So if we're doing y is greater than or equal to 5x, remember for a hot second, I just ignore the inequality and I'm going to graph the line y equals 5x. To put that as a linear equation, it's y equals 5x plus nothing. So you got to remember where you're asked to start on the graph. This constant at the end, this b value, that's always your y-intercept, if you remember that. So I'm going to start by graphing at 0, y equals 0. So that's that last constant number there. That's called your y-intercept. It's the spot where your graph crosses the y-axis. It's also the b value in your y equals mx plus b there. So I start at 0. And then I count off my slope. And you might remember that your slope is just a number in front of x, or the coefficient of x. And in this case, the slope is 5, which is like 5 over 1. So to get my next point, that means I have to go up 1, 2, 3, 4, 5 units, and across 1 unit. So up 5 over 1 gives us the point 5, 1. 1, 2, 3, 4, 5 over 1. You can do it again. 1, 2, 3, 4, 5 over 1. And I start to see that linear pattern for y equals 5x. But you got to remember that we're not graphing y equals 5x plus 0. We're asked to graph y is greater than or equal to 5x plus 0. So since we're allowed to be equal to, I'm actually allowed to draw a solid line there. And now we got a shade because we wanted values greater than or equal to that line 5x. So since we're looking for y values that are greater than or equal to, I go to the spot on the y-axis. So again, your y-axis is your vertical axis here. I would go to where the y values are greater than this line. So y values that are greater than the line are going to be these y values that are above the line. So that kind of tells me where I need to shade. That means I'm shading above this line. And what you need to remember is that the answer to a solution of linear inequalities is actually the spot where the two colors overlap. So it's kind of my purpley looking region there. That's actually the answer to the problem. You can always grab a test point, pick any point you want and use it to check. Grab an easy one, like, I don't know, looks like -2, 2 might be a good one to grab. And you would just, take a second to make sure that that point actually works in both inequalities. And fun fact, a y value of 2 there is going to be bigger than -3. And then if I let x equal -2, 5 times -2 is -10. And this y value of 2 will always be bigger than -10. So that works. That's how we know we did it correctly. So the answer to this problem, I'm just going to make it definitely something you could see, is this purple region. right in there. So your answers on your homework are a little weird. They're not like numbers today. They're like regions on a graph. Nice big set of points there is our solution region. All right, I got one more for you. Okay, so let's practice y equals x minus 1. So if I do y equals x minus 1, I'll do that one first. So again, I temporarily, in my head, kind of ignore the less than symbol, and I just focus on graphing y equals x minus 1. And you could put that in y equals mx plus b form. So the slope is 1, and the y-intercept is -1. So that's your starting point on the graph. So you go to the y-axis because it is a y-intercept, and you got to go to the point -1 on your y-axis. So I'll graph that point right there. And then the slope of this line is 1 over 1. So since your slope, or your m value, is 1 over 1, that tells us we're going to go up 1 and to the right 1. And that's how I get my points. So I'll go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. We could repeat this pattern in reverse. And now comes some decision-making time. I got this less than symbol here. So the solution region for this inequality has to be strictly less than the line. In other words, less than means smaller than. So I go to the spot on the y-axis where my numbers are less than the line. So like -10 is definitely less than that point right there. So that tells me where to shade. So I'm shading below the red dashes there. And then I do have to decide solid or dashed. And since I want values strictly less than, this line right here is actually a dashed line, because this line itself isn't allowed to be part of the solution to the problem. It just is kind of like, you know, maybe like an electric fence for your dog, you know. It's not really there. We can't really see it. It kind of sets up a nice boundary for us, for our solution region. So that is the solution region for the first inequality. But, oh yeah, we got 2 of them because it's a system. So we'll go ahead and graph y is greater than or equal to x plus 1. In my head, I kind of ignore that greater than or equal to symbol. And I'm going to graph a line with a slope of 1 and a y-intercept at 1. So that y-intercept is always our starting point of the graph. So I go to the y-axis and I put a dot where it tells me to. It tells me to put a dot at 1. And then I got to go up 1 over 1, up 1 over 1, up 1 over 1. And you can repeat that pattern in reverse. Notice this time around it says greater than or equal to. So I'm allowed to be equal to this line. This is like a real fence. Interestingly enough, since we have the same slope, our lines are parallel. I don't know if you guys have gotten into all that yet, though. And then it does say I want values greater than or equal to that value. So if I'm going to go greater than the line, that means my y values have to be greater than the line, or the values of the y-axis I'm going to choose to shade are above, because above is greater. I'm going to choose values on the y-axis that are above my blue line. So values that are above my blue line, if this is my blue line, values on the y-axis that are above it are up here, which means I have to shade all of this business here. And what's interesting enough is see how there's no overlap for this system? That actually means there's no solution for this linear system. There's no common region. Even though we colored stuff in, they don't have any points in common. So this problem actually has no solution. And you would just write it like that. This one has no solution because there's no points in common. Alrighty. I certainly hope this helps you along.